Hello friends, my new channel will cover all the science topics of class 9 and 10. Previous video was just an experiment. Regular topics will be covered here, and if you need to learn things, learn from here. Starting from chapter the motion. Coming to its definition. A body is said to be in motion or moving when its position changes continuously with respect to a stationary object taken as reference. Suppose you go out to your house of your friend. Now clearly if you go from your house to your friend's house, you certainly cover a distance, and your motion and you are in motion, that is your position keeps on changing till you reach your friend's house. Now I have mentioned a topic reference. Now what is a reference? Suppose you are in a train. Suddenly you feel that trees outside are moving, but it is not true. You are moving with the train. So here, with respect to tree outside, you are moving. Tree is the reference here. Let us take another example. Now, if you are riding a bike, then you are in motion with respect to your house or any building there. Here, building is the reference. Similarly, our earth is also in motion with respect to the sun. Here, the sun is the reference. You can clearly see that the earth, here the sun and the earth. The earth is revolving around the sun, where the sun is the reference. Now let us discuss something about distance and displacement, which are important terms of the motion. Distance. It is the actual path covered by a moving object irrespective of the direction in which the body is moving. Displacement. It is the shortest path between initial position and final position of the body. Distance is a scalar quantity. Displacement is a vector quantity. Distance can never be zero, but displacement can be zero. We have discussed about scalar quantity and vector quantity, which will be discussed in the next slide. Again, let us take an example. For instance, you drove to a mall which was 3 km away from your house and came back to your home. So you covered a distance of 6 km, while displacement will be the shortest path from the initial position to final position. So displacement will be 0 and distance 6 km. Another example is waiting for you. Suppose a man starts walking from a point A, and this is point A, and finishes his walk after covering this whole path back to point A. Now here the distance will be equal to the circumference of the circular path, that is 2 pi r, and the displacement will be 0. Another example, let a person goes from point A to point B and then point B to point C. If A to B is 7 km, B to C is 3 km, then the total distance traveled will be 4 plus 3 that is 7 km. But the shortest distance will be directly from A to C, which will be 5 km according to Pythagoras theorem. Now scalar and vector quantities. Scalar quantities are those quantities which has only magnitude and no direction, because there is no need to mention the direction in this in these quantities. For example, speed, distance, weight. We never say that the speed is 4 kilometer per hour in this direction, or the distance, that is 4 meter or 4 kilometer in this direction, weight 5 kg toward north. This is not acceptable. So these are called scalar quantities. Now vector quantities are those which requires both magnitude and direction to be justified. Example, velocity, displacement, force, etc. We say 5 km per hour towards west, that is velocity, that becomes velocity, and 5 Newton force downwards or upwards, both are directions. Now next topic is uniform motion and non-uniform motion. A body is in uniform motion if it covers equal distance in equal interval of time. Suppose you are traveling and the vehicle in which you are traveling, it covers 5 km in 5 minutes, another 5 km in another 5 minutes, then the body will be said to be in uniform motion. A body is said to be in non-uniform motion if it is covering unequal distance in equal interval of time. For instance, it covers 10 km in 5 minutes, another 20 km in another 5 minutes, then will be said to be in non-uniform motion. In uniform motion, the graph between distance and time is a straight line, and in non-uniform motion, the graph between distance and time is a curved line. Next part of this chapter will come soon on YouTube. We will discuss speed, velocity, acceleration, equation of motion, and numerical problems. Subscribe us and please comment to improve next sessions. Thank you.